Hello, everyone. Welcome back to Mntabisimhlongo's Mathematics and Physical Sciences YouTube channel. Uh, I know we have been away for a while before the trials, and now it's time to prepare for the final exams. And hopefully, we'll be posting more and more videos. And in today's video, we are looking at the Mpumalanga trial exam from Physical Science Paper 1, the September 2024 paper, and our focus is on question 2, which is basically um, Newton's laws of motion. Now, in question 2, we are given a block P of mass 5 kilograms, as you can see from the diagram, that is placed on a rough surface that is inclined at an angle of 30, and the 30 is being shown there, to the horizontal. So it's a 30 angle to the horizontal. It is connected to a second block of mass 2 kg, which is block Q, by a light inextendable string passing over a light frictionless pulley, and there is an average constant frictional force of 2.5 newtons that acts on the block P as it moves on the incline, as shown on the diagram. So we ignore the effects of air resistance. Now, the first question that is being asked here is that state Newton's second law of motion in words. And I would like to first do this. Okay, 2.1. Newton's second law. Whenever I talk of Newton's second law, this comes up in my head. F net is equals to ma. I mean, for most of the definitions or laws, they come with a formula. And this is the formula where Newton's second law is best explained. I would like to write the Newton's second law down first. So, Newton's second law of motion states that when a net force, excuse my handwriting, when a net force acts on an object, the object itself, the object will accelerate in the direction of of the force and the acceleration is directly proportional to the net force, or you can call it the resultant force. So when you're writing the definition here, you can either choose to write resultant force or you just write net force. And inversely, proportional to the mass of the object. So in a nutshell, if you can go back, it's quite a long, a lengthy when I write it down here, but in a pen and paper, it is very short. Fnet is equal to MA. Let's go back to it. So Fnet is equal to MA. The law says that the object will accelerate in the direction of the force and the acceleration is directly proportional. So it means acceleration is directly proportional to what? To F net. Where does that come from? If we make A the subject of the formula, we're going to get what? F net divided by M, which means A is directly proportional to F net, meaning an increase in A results in an increase in F net. And then an increase in A results in a decrease in M because they are inversely proportional. So A is inversely proportional to M, such that a decrease in A results in an increase in M. And that is basically Newton's second law. They are inversely proportional. Well, I think I need to correct something here. A increase in A doesn't necessarily mean a decrease in M because you can have you will have to have a constant a variable M if A is changing. So M stays the same, but A can change, or A stays the same, and if M can change, it's more or less like that. But anyone can have a comment on that. You know, this is just for formalities to try and understand the relationship between the three variables. Uh, if we go back to 2.2, in which direction will the system move? So you have a system like this. I need to redraw it. You're having a system like this where this is being pulled 2 kg, 5 kg, and this is a pulley system. I look at this as this is a greater mass, this is a smaller mass, so this will go up such that the direction is going to be to downwards of the incline, which is this here. So it's going to go down the incline, down the incline. Then we have 2.3. Now in 2.3, they want us to draw a free body diagram for block P as it is moving on the incline, which means down the incline. And the max is 4, which means there are 4 forces they are looking for, right? I always tell my learner to just do a small dotted line to show the incline. Then they do this dot that is huge, which is free of a body. Then they can tilt such that the dotted line that they drew is horizontal. Like if you tilt your paper and you make it horizontal, then you can make a 90 degrees here to make Fn, which acts perpendicular to the surface. Then take it back to the normal paper and draw your WFG straight down because it's always going down. And I'd advise learners to avoid drawing components, as you will see in the next question. Um, then next up, if our object is going in this direction, that means its friction is opposing and going in this direction. Therefore, our friction has to go in this direction. And this is tied up to a string that has what? Tension. And those are one, two, three, 4 marks. Okay. Then in 2.4, in 2.4, the question is asking to apply Newton's second law to each of the blocks and calculate the magnitude of the acceleration of block P while moving on the incline. Now we need to go back to the statement. Block P of mass 5 kilograms is placed on a rough surface that is inclined at an angle of 30 degrees to the horizontal. It is connected to second block Q of mass 2 kilogram by a light inextendable string passing over a light frictionless pulley. An average constant frictional force of 2.5 newtons acts on block P as it moves on the incline, as shown in the diagram below. So there is nothing being spoken by a constant velocity, so we can't just assume acceleration like that acceleration is 0 or acceleration is 9.8. Nothing is being said. So we don't know the acceleration. That is why the question is also asking us about acceleration to be calculated. And it says we need to focus on what? Block P and apply Newton's second law. Now, in block P, what are the forces that are acting? So we drew the forces in 2.3, but now we can calculate Fg when we have an inclined surface from the way I said people, learners must draw. If I can just take it back here, we can't do any calculation whereby we have this Fg here that is just straight down to the ground. So we need to redraw our free body diagram now with the components of Fg before we can proceed with the calculation. So we start with the free body, Fn, tension, friction. Then the one that goes down is Fg perpendicular because it's perpendicular to the surface of the block. And then Fg parallel. Now we have an object that is going to this direction, which means this direction we can choose it to be positive, and any force going to that direction will be negative. So we can start by saying what? F net is equals to ma. Now the mass of the object is given by 5 kilogram. Acceleration, we don't know. F net, what is it comprised of? This force, this force, this force, and their direction. All right. So we'll start by our FG parallel, which is positive, plus put it in brackets. As you can see here, tension is going up, so it's negative. Friction is going up, so it's negative. So we'll start by either negative friction plus a negative tension, which is equals to mass times acceleration. Fg parallel is equal to mg sine of theta. And if you know sine is given by SOHCAHTOA, which is what? The opposite side over the hypotenuse. Now, if we make a hypotenuse here, this one is opposite and this one is adjacent because the angle would be here. Right. Okay. So this is mg sine theta. Now this angle here is this angle that comes from the incline, which is theta here. And this is minus friction minus tension is equals to mass times acceleration. And that is still in block P. Right, let's do substitutions. The mass is 5 times 9.8 times sine of the angle 30 degrees minus, we had a friction here. Now friction, they said in the statement, is 2.5 newtons and it's constant friction. So it's minus 2.5 minus T is equal to 5A. And if we do the calculation for this one, we're going to get 22 minus, so if we do the whole calculation of 5 times 9.8 times sine 30 minus 2.5, you get 22. Then minus t is equal to 5a. So we see that we have two unknowns here, but the one that doesn't have a coefficient is t, so we can take t to the right hand side and 5a to the left hand side to get 22 minus 5a is equals to a t. Then we stop right there. We'll continue to block Q. Block Q. Now block Q, as you see from this diagram, block Q is just having tension and gravitational force. If we can draw them, you just have this tension, excuse me, and gravitational force. So the object is moving to this direction. So it means upwards here is positive, downwards here is negative, and therefore, if we say F net is equal to the mass times acceleration, nothing has been said about acceleration or velocity being constant, so we can't assume A is zero. The mass of the object is 2 kilograms, so F net is comprised of what? A positive T minus Fg, which is equals to 2a if you just substitute. Now, t minus mass times gravity is equals to 2a. T minus 2 times 9,8 is equals to 2a. Then t minus 19.6 is equals to 2a. We also have two unknowns here, but we can make t the subject of the formula. So t is equals to 2a plus 19.6. Now, we have made here an equation with t, which we can label equation 1, and we have now here an equation with t, which you can say equation 2. Now, equation 1 is equals to equation 2 because the tension is the same. These two blocks are being pulled by the same string, right? Okay, so the first equation says what? 22 minus 5a is equals to t. So you can just say t is equals to t. 22 minus 5a is equals to 2a plus 19.6. Now we take 19.6 to the left, it becomes 22 minus 19.6 is equals to 2a plus 5a. If we do the subtraction, we get something like 2.4 is equals to 7a. And then if we divide both sides by a 7, we get that a is equals to 0.34 meters per second square. Okay, then we've gotten our acceleration. Next question. Oh, this is our last question. If the string between block P and Q now breaks, how will block P's acceleration compare to the calculated in question 2.4? Choose greater than, smaller than, or equal to. and you give a reason. So we chop off the string. If we chop off the string, definitely the object was going down, but at a small acceleration. So the acceleration is going to be greater, or it's going to increase, basically. Why are we saying that? When the object was already going down, and now you're chopping off something that was restricting it to go down quicker. So in 2.5, you can just say acceleration becomes greater. And why is that? There is more string. There is no more string. There is no more string, and the string comes with what? With tension, which is a force that was opposing it to go um, down the slope quicker. There's no tension pulling it. And as we explained in Newton's second law, if the acceleration becomes greater, that means the net force increases. So F net increases as is directly proportional, as it is directly proportional to A, which is acceleration. Right. Thank you for tuning into our video. Please stay tuned, share, like, subscribe, and we'll see you in the next video and the next topic. Thank you.